This video is electricity topic number 3. Once again, if you take a look at your notes and focus on topic number 3, just a few small items that I want to discuss about this particular section. So topic number 3, we're really just looking at two main things. The first one is looking at the idea of electron flow. So we're looking at this. Electron flow is when we look at electrons, which really is the flow of electrons. It's moving from negative to positive. And again, that's probably what you would have looked at in grade 9. A negative to a positive is kind of that shuffling of electrons. It's the flow of electrons. It doesn't really move in that single file, one by one, all the way around. It does more of a shuffling. And what I mean by that is, as you shuffle, it's a whole bunch of electrons that are coming together. So if I had, say, this line as my guide, and I had all these electrons, every one of these dots is an electron. When we have this movement, or this Coulomb, so this would be a whole bunch of electrons moving here. So this, say, this is 1 Coulomb, which is equal to 6.24 times 10 to the 18 electrons. Right, we had all these electrons here, and what happens is these electrons, and again, if you think about electrons, think of chemistry, they're rotating, vibrating, moving back and forth, and so they don't just move in this nice, easy, if there's an electron, it follows this next electron, and it's nice, smooth line. Electrons, these guys are moving all over the place. They're bouncing off each other. Sometimes they move this way, sometimes they move this way, sometimes they're up here, sometimes they're bouncing off this side, they're bouncing off this next electron, and they keep moving around, and it's very random. So when you have electricity moving through it, it's all these random movements, and so when we talk about 1 Coulomb of charge, we're looking at a net movement of electrons. So some of them, shuffle this direction, some of them will eventually shuffle this direction, but as a group, once you have 6.24 times 10 to the 18 electrons kind of passing this line here that I drew first, that line then would indicate 1 Coulomb of charge passing by. Because it's so random and really the net movement isn't that far, in fact, when you turn on a light switch, electrons actually don't move very far at all throughout the whole day. If you kept lights on the whole day, the electrons themselves might move about a meter. And that's just because they're kind of shuffling around and they're going in this random order. But at any given moment in time, if I drew that line, so if I drew another line here, if I analyzed how many electrons were moving back and forth in this particular line, if there are 6.2 times 10 to the 18 electrons moving back and forth across that line, then that would be 1 Coulomb of charge. It's just that this line is happening everywhere, right? It's happening over here, it's happening here, so that's just our reference point. So at any given line, when they're moving back and forth, and there's that net movement of this many electrons, then we'd say it's 1 Coulomb. So an electron flow is saying that these are moving, these are moving from the negative terminal to the positive terminal of a battery. So that's electron flow. That's really what's happening. Now, when we start looking at the textbook, you start reading through it, then they start talking about what's called conventional current. And conventional current is complete opposite to the flow of electrons. We use conventional current because, well, there's not really any good reason. They originally thought that electricity moved in that direction. So they thought it went from positive to negative. They built all their math and all their equations around going from positive to negative. So really, in a nutshell, instead of changing everything when they discovered it actually went from negative to positive, they kept everything in the positive direction. So what you'll find is the reason they call it conventional is because that's the original thought. All our circuit diagrams are set up that way. All our math equations are set up that way to always get a positive result. The absolute number, if you decide to do analysis of the numbers going an electron flow, you're going to get the exactly same number. It's just that it's going to be a negative number. So to avoid negatives and positives and so on, we continue to use conventional current, and that's really, to be honest with you, the only reason why we do that, and it's just kind of a standard practice now. So when you read through the textbook, all the diagrams and the problems will be based on conventional current. And that's really all there is for topic number